Hi guys, this is Rakesh Talreja and I welcome you to BYJU'S exam prep. And first of all, heartiest congratulations to all of you for the 77th Independence Day of our nation. Yes, we have completed 76 years of independence, and definitely it should be a moment of joy. It should be a moment of pride, all of us, right? At the same time, for all the students, especially the GATE aspirants, for you, what would be the true freedom, what would be the true independent is, conquering your dream eventually. Yes, eventually when the GATE 2024 results will be declared around 15th of March, you should be looking yourself getting the best possible rank as per your efforts. We know that all these occasions, definitely brings up some positivity. It brings up joy to our lives, but at the same time, each and every day is also important for a GATE aspirant. So, I believe, you might have been preparing for a lot of time, and that is why again I'm repeatedly telling each and every single day matters for an GATE aspirant, and that is why on this occasion as well, the BYJU'S exam prep thought. Our entire team thought, let us present to you, maybe not taking a lot of time, but at least present to you a GATE 2024 mini mock test. What this mini mock test is going to comprise of, I'm going to tell you, so that all those who are really serious and want to prepare and practice even on, every possible day. Today, you're going to practice several questions with us in the form of GATE 2024 mini mock test. Now, let me tell you what this mini mock test actually will comprise. So first of all, because it's mini mock test, it's not 100 marks, it's going to be for 50 marks. There will be 10 questions of 1 mark and there will be 20 questions of 2 mark. That is how it is going to be 50 marks. And what are the subjects you are going to see? The subjects you are going to see here will be engineering mathematics, signal and system, network theory, control system, digital circuits, analog circuits, and electromagnetic theory. These are the different subjects you are going to see. So we have chosen the subjects, which are, fundamentals, mostly fundamental subjects, especially network, control, digital, maths. These are under fundamentals only, and especially those subjects which are common for ECE and EE, so that both the students get the benefit of this mini mock test. So without wasting any more time, let's get started with the first question. I'll be taking the questions from engineering maths and signal and system, and then later on, Ashu Jhangra sir, Sanjay Rathi sir, Saket Verma sir, all of us, are going to contribute to this particular event. So once again, I wish you happy Independence Day to all of you, and let's get started with the first question. Now, what you can do is, guys, with every question I present, I'll start giving you the solution as well. So that we keep on moving in a continuous discussion pattern. But those who have already completed the subjects and they have the confidence, yes, whatever question I'm going to present, you have the confidence that yes, you can attempt it, you can solve it. So what you can do is, whenever I present the question, you can pause the video, solve it on your own, and then come and check whether your answer matches with me or not. If it matches, perfect. If it doesn't matches, you can check on the solution. So that's what. Moving ahead with the first question here, I'm starting with engineering maths and then I'll go to signal and systems. So consider it's a 1 mark NAT question. Consider a non-singular 2x2 square matrix A, and if the trace of A is 5, trace of A square is 6, what is the determinant of the matrix? Trace and determinant, if you're able to recall, are related with the eigenvalues. The eigenvalue properties can be used here. So suppose the matrix A has the eigenvalues lambda 1 and lambda 2. So what would be the eigenvalues for A square? For A power n, it is lambda power n. So lambda 1 square and lambda 2 square. Now what is given to you is trace of A. Trace of any matrix is equal to sum of eigenvalues. So trace of the matrix A should be sum of the eigenvalues. See why I have taken 2 eigenvalues? Because you have been given a 2x2 matrix. So lambda 1 plus lambda 2, that is equal to 5. Also they have given the trace of the matrix A square, and as per this eigenvalue property, it should be sum of eigenvalue, that is lambda 1 square plus lambda 2 square, and that should be equal to 6. Right. Now what you can do is you can just simply apply the property, that what is the lambda 1 plus lambda 2 whole square? Lambda 1 plus lambda 2 whole square is a square plus b square plus 2ab. That's what you're going to apply. So lambda 1 plus lambda 2, that is 5. 5 square is equal to lambda 1 square plus lambda 2 square, that is equal to 6. Plus 2 lambda 1 lambda 2. Now dear, what is the determinant of the matrix? And the determinant of the matrix, the determinant of matrix, again related with eigenvalue, is given by the is given by what? Is given by product of eigenvalues. This should be equal to lambda 1 into lambda 2. This should be equal to product of eigenvalues, and that is already obtained from here almost. So solving from here, what should be lambda 1, lambda 2? So it's going to be 25 minus 6, 19. 19 by 2, it's going to be 9.5. It's going to be 9.5, and here is your answer. That is equal to 9.5. 9.5. This is the answer for the first question. Okay, and keep counting your score. If you have got the correct answer, okay, you can add on to 1 mark, because this is a 1 mark NAT question. Let's move ahead to the next question then. So I have the next question here. Find the solution of the differential equation dy by dx equal to ky, given that initial value y0 equal to the 4. Given the initial value of y0 equal to the 4. So let's get moving. It's again a 1 mark MCQ question, and simple one only. Okay, so dy by dx is equal to ky. It's a variable separable simple case. Divide y on the left side and get the dx on the right side. So dy upon y is k dx. Integrating both the sides, 1 upon y integral is log y, and that is equal to k. Dx integral is x plus the constant of integration. So ln y is equal to kx plus c. Now I am going to use y0 equal to 4. That means when x equal to 0, y will be taking the value of 4. So log of 4 is equal to x ki jagah 0. Okay, so 0 plus c, and hence you can conclude that the value of c, okay, that is the unknown constant, is log 4, the constant of integration. So now I have log y is equal to kx plus c, and c is now equal to log 4. Bring all the log terms on left side. So the log y minus log 4, okay, will be log y by 4. Log a minus log b is log of a by b. So log of y by 4 is equal to kx. So what is going to be y? Okay, we need in terms of y or in terms of x. We'll see how it can be arranged. Okay, yeah, exponential options are there, so definitely y ke form mein aayega, because y by 4 is equal to e raised to the power kx, right? Y by 4 is equal to e power kx. So y is equal to 4 e power kx. Okay, y equal to 4 e power kx. Option number C is the very correct option. This was the next 1 marker MCQ question, right? Hope you are enjoying it, and if you are enjoying it, hit the like button to put your attendance. Okay, show your response, show your attentiveness to the session. Third question, 2 marks, numerical answer type. Third question for 2 marks, that is the numerical answer type. The contour C given below is on the complex plane z equal to x plus jy. What is the value of the integral? 1 upon pi j, integral over the contour C. Okay, 1 upon z square minus 4. Okay, so you know, if I separate out the function, what is the function fz given to me? Okay, that is 1 upon z square minus 4. Okay, so let me take it here once again. Fz is given to me as 1 upon z square minus 4, and if I just evaluate the poles of this, so I am going to get z square minus 4 equal to 0, that is z equal to plus or minus 2. Okay, now as per the simple analysis given here, as the curve given here, both are inside. Z equal to 2 and z equal to minus 2. These are the two poles, and both are inside the contour. Right, everybody able to observe that both are inside the given contour. Okay, but okay, the pole z equal to 2. Okay, now let me mark it by the pole sign. This is one of the poles, z equal to 2. This is another pole. Okay, if I talk about z equal to 2, that is being encircled. That is being encircled in what direction? Okay, this is known as the direction of clock. Right, so this is encircled clockwise, but the pole z equal to minus 2 is encircled anti-clockwise. Okay, see, this is encircled anti-clockwise. Right, this is encircled anti-clockwise. No, I think there is some error with the this is anti-clockwise. If I take this, yeah, there is some error with this diagram. I'm sorry, I'll correct it here. Otherwise, the flow of arrow doesn't match. Okay, so isko maine clockwise bola, so I'll just reverse this, guys. Otherwise, it's impossible. The flow doesn't match. This is going like this, the closed path, and then this is going to be like this. So I switch this arrows. Okay, or either I can switch that side arrow. Any one of them I can switch. Okay, so this is encircled anti-clockwise. Okay, now we know that the positive direction of integration for a closed curve is the anti-clockwise direction. So this part is okay, but whatever integral you calculate, normally by the residue method, you have to place a minus sign whenever it is the clockwise encirclement of the given pole, isn't it? So guys, first of all, what is the residue of both of the pole? Let's apply the residue method, or if you want, you can apply the Cauchy integral formula as well. But let me take up the residue method. F of z is 1 upon z square minus 4, or that is 1 upon z minus 2 into z plus 2. I have factorized it. Okay, now what is the residue for the pole z equal to 2? For the pole z equal to 2, it is given by limit of z tending to a. Okay, because both of them are simple poles. Simple pole means the pole occurring once only. Okay, the pole of first order only. The limit z tending to 2, z minus 2 into fz, z minus 2 into fz. So z minus 2 will get cancelled. Okay, and then right here, this z minus 2 term is cancelled, and then I'll substitute z tending to 2, the 1 upon 2 plus 2. So this residue is 1 by 4. Now, what is the another residue? That is the residue for z equal to minus 2, and that is given by limit z tending to minus 2, z minus minus 2, so that will become z plus 2 actually, into fz, that is 1 upon z minus 2 into z plus 2. Again, you are going to feel that z plus 2 this time is cancelled, and now put z tending to minus 2, and if you put z tending to minus 2, it is going to be 1 upon minus 2 minus 2, that is minus 1 by 4 actually. That is minus 1 by 4. Correct? Eh? Yeah, sure. That is minus 1 by 4. Now, normally what you do is, okay, now the question is 1 upon pi j integral z 1 upon z square minus 4. Okay, the question is 1 upon pi j integral over the closed contour 1 upon z square minus 4 dz. Okay, and I've called this 1 upon z square minus 4 as fz. So this should be equal to 1 upon pi j, and as per the Cauchy residue theorem, the integral fz dz is 2 pi I or 2 pi j into summation of residues. Okay, that is what the Cauchy residue theorem says. So twice, right, into summation of residue. Now residue of z equal to 2 and residue of z equal to minus 2. Okay, but you have to pay attention that, as I told you, z equal to 2 is encircled clockwise, so its final residue value will be considered negative and another one will be positive. Okay, why this is negative? Let me write down once again in front of you. Why this one negative? Because it is minus 1 by, because it was clockwise, not the value I want to write, because of the clockwise. Okay, another one will be plus because of anti-clockwise. Okay, because of what? Because of the anti-clockwise. So now this should be equal to twice. Okay, what was the value for residue? Z equal to 1 by 4. So I will put it as minus 1 by 4. Next is plus residue of z equal to minus 2, which is further minus 1 by 4. Okay, so this is equal to twice minus 1 by 4 is minus half, and the final answer stands out to be minus 1. The final answer stands out to be minus 1. Is that clear, everybody? The final answer very, very clearly is turning out to be the minus 1. Right? If both were in the same direction, if both the encirclements were in same direction, so residues will cancel each other and then the answer would be 0. But here that is not the case, and eventually my answer is equal to, let me change the arrows here as well. Yeah, so eventually my final answer has turned out to be minus 1. Okay, this is the complete path you are able to trace, and the answer is equal to the minus 1. Clear? Minus 1. Okay, this was a 2 marks NAT question. Moving ahead to the next question, dear. Okay, what is the next question? A 2 marks NAT question. Once again, a continuous random variable x has the probability density function k x square e power minus x. What is the variance? Now, before you calculate the variance, you need to know what is the value of k, right? First of all, before you go to the variance, the PDF function itself is incomplete because there is a known value k, right? And to find out the value of k, you can use that integral fx dx is always equal to 1. Okay, the area under the PDF is always equal to 1. In general, the integral is from minus infinity to infinity, but you can also solve it integral 0 to infinity fx. Because here the x is greater than 0. Okay, so k x square e power minus x dx. Okay, this should be equal to 1. K is outside. Now guys, you might be thinking that this is a lengthy question. Okay, because a lot of integration is going to come. Definitely if you are going to integrate, it's a lengthy question. But how to simplify it? Okay, how to simplify it? Simply use the fact that integral e power minus x raised to the power n. Yeah, x raised to the power n minus 1 dx is given by the gamma n. Okay, if you use the gamma function, then this question is like very simple for you. Right? So what is the value of n here? N minus 1 is equal to 2. Okay, n minus 1 is equal to 2. So n is equal to 3. So this is like k gamma 3 equal to 1. What is the value of gamma 3? The value of gamma 3 is factorial 2. The value of gamma 3 is factorial 2 because for integral values of n, see, gamma n plus 1 is equal to factorial n for n equal to positive integer. For n equal to positive integer, right? So k into gamma 3 means factorial 2. This should be 1 and that means k is equal to 1 by 2. Factorial 2 is 2, so k is equal to 1 by 2. Okay, now this is only one part of the question. Now next is variance. For variance, I would be needing the mean as well. Okay, so what is the expected value of x? The expected value of x is integral x fx dx. All of them will be solved by gamma function. This is the general formula, integral minus infinity to infinity x fx dx. But now the limits will become 0 to infinity because fx is defined only for that limit. X into kx square e power minus x dx. Right. So this is going to become k outside, integral of e raised to the power minus x cube dx. Okay, limit 0 to infinity and x cube. Okay, this is 4 minus 1. X power, sorry. This is what is n minus 1. This is what is n minus 1. So n is equal to 4 this time. N is equal to 4 this time. And this is equal to k. What is the value of k? K is equal to half of gamma 4. Right, that will be half. Gamma 4 is factorial 3. 6 divided by 2. The mean value is 3. They can even ask the mean value which is equal to 3. But they have asked the variance. Okay, so expected value of x square, integral x square fx dx. Integral x square fx dx, integral 0 to infinity, and now this is going to become k again outside, integral 0 to infinity, x square multiplied by the x square of the fx, so e power minus x, x power 4 dx, n minus 1 is 4, so n will be 5, so this time this is equal to k gamma 5, the value of k is half, gamma 5 is factorial 4, 24 by 2, this is equal to 12. Now the variance, by the final identity, we know that the variance is given by expected value of x square minus expected value of x whole square. That is a very, very important variance property. Okay, right. Mean square value minus square of the mean. So e of x square 12 minus mean value was 3. Okay, so 3 ka square. So 12 minus 9, the variance answer should be equal to 3. The variance answer, numerical answer type, this data is equal to 3. Right, dear, this was the fourth question for us. Moving ahead to the next. The fifth question of the maths, the fifth and the last one, and then we'll have the question from signals coming up. Okay, it's a question based on vector. The derivative of f at the point 1, 2, 1, okay, in the direction of a given vector is 2 root 3, in the direction of another vector is minus 3, and in the direction of some another vector is minus 2. What is the directional derivative in the direction of ax plus 2 ay minus 3z? It's a good question. Okay, 2 marks MCQ question. Now, in general, if you have to recall, dear, okay, derivative in a given direction. We call it as directional derivative. Directional derivative of any function f, of any scalar function f, right, in the direction of any vector a, right, okay, at the point p. The directional derivative of the scalar function f at the point p in the direction of a is given by the formula gradient of f dot product a hat, gradient at the point p dot product with the a hat, okay, that means it is going to be, okay, gradient at the point p dot product with vector a divided by modulus of a, because a hat means unit vector. Okay, now the directional derivative of f at the point 1, 2, 1 in the direction of the given vector ax plus ay plus az. Now, see, what is the gradient formula? Okay, first case mein you are given along the vector a. What is the vector a? Ax plus ay plus az. ax plus ay plus az, right? So what is going to be the gradient of f? What is going to be the gradient of f? So what is the gradient of f? Yeah, directly directional derivative लिख लेते हैं. So directional derivative is gradient of f. We know the gradient is given by del f by del x into ax, del f by del y ay, plus del f by del z, okay, into az, dot product with vector a, that is ax plus ay plus az, divided by its magnitude, that is root over x square plus y square plus z square. So here it is root over 1 square plus 1 square plus 1 square. Okay, eventually when you take the dot product, x to x component will multiply, and this is 1 by root 3. Acha, 1 by root 3 is outside. Okay, and then you are left with del f by del x into 1, that is del f by del x, then similarly del f by del y plus del f by del z. Now what you are given, this directional derivative, okay, this directional derivative is 2 root 3, right, is 2 root 3. So 1 by root 3 of del f by del x plus del f by del y plus del f by del z is equal to 2 root 3, is equal to 2 root 3. So from here you can write down what is the value of del f by del x plus del f by del y plus del f by del z is equal to 2 root 3 into 3, that will become 2 3s are, that is equal to 6. Now this is, suppose one of our equation. Suppose this is one of our equation. Okay. Now, okay, the point is same, the derivative at this point, okay, in the direction of, when first vector is 2 root 3, in the direction of the vector minus 3y. So, second example देखेंगे, right? In the second case, the vector a is given to you as minus 3ay, Okay, so what is going to be its unit vector? Divided by its own magnitude only, nothing much here. So, what is the directional derivative? The directional derivative, gradient, that is del f by del x ax plus del f by del y ay plus del f by del z az, okay, dot product with minus 3ay divide by 3, divide by its magnitude 3, okay. Now when you take the dot product, you only get del f by del y into minus 1. So minus del f by del y. And what is the directional derivative given here? It is minus 3. Okay. This is equal to minus 3. So from here, you get del f by del y equal to 3. Suppose this is the second result. And similarly, third result, in the direction of another vector. What is the direction of another vector? Another vector is minus 2az. Okay, in the direction minus 2az, directional derivative, which is del f by del x ax plus del f by del y ay plus del f by del z az, dot product with vector a divided by its magnitude, which is 2, right? So ये कितना हो जाएगा? It's only z to z component multiplied. So this is minus del f by del z, and this is given to you as minus 2. You can note the question again. So from here you have obtained del f by del z is equal to 2. Suppose this is the third result. Okay, so you can substitute the second and third result in the first one, so you get the del f by del x also, right? तो अगर first पे आ जाएंगे वापस, so I have del f by del x plus del f by del y, I'll directly substitute the value, which is 3, plus del f by del z 2, okay, is equal to 6. In the first equation, it is equal to 6. So what is the value of del f by del x? Very simply, the value of del f by del x is equal to 1. 6 minus 5, that is equal to 1. And now finally, the question is, what is the directional derivative in the direction ax plus 2ay minus 3az? Ax plus 2ay minus 3az. Okay, let me take the next case. Okay, now the vector a is given to you as ax plus 2ay minus 3az. So directional derivative is given by del f by del x ax cap, del f by del y ay cap plus the del f by del z az cap, dot product with the vector a divided by its magnitude, that is root over of 1 square plus 2 square plus minus 3 square. So this is going to be del f by del x into 1. Okay, that is del f by del x plus 2 del f by del y, and then I will substitute the value. Minus 3 del f by del z is whole divided by under root of 1 plus 4 plus 9. 1 plus 4 plus 9, so root 14 will come, and now del f by del x is 1, del f by del y was 3 if I'm not wrong, yeah, and del f by del z is 2. Okay, so minus 3 into 2, and that is whole divided by root 14. Okay, so answer should be 1 is divided by under root 14. Let's go and match the options then. 1 is divided by root 14, 1 is divided by root 14. Yes, option number C is ready for us. We have the option number C ready for us. Done, hai ji? Okay, right. So these were the 5 questions of maths, 2 questions 1 mark and 3 questions of 2 marks. Okay, and now moving ahead to the questions. Okay, from signals. Okay, a 1 mark MSQ question, please make a note. A 1 mark MSQ question. Consider the following statements related to the impulse train, okay, with the time interval of 10 seconds, and that is defined as, okay, what is the impulse train given to you? mt is equal to 5 summation delta, okay, summation delta t minus nts, okay, yeah, t minus 10n, okay, summation n is minus infinity to the infinity, and this is what is going to be known as the time period of the impulse train. Okay, now impulse train is an important topic in signals. You study about impulse train and its Fourier analysis as well. What is the trigonometric Fourier series, CK or CN in general? Okay, the trigonometric, the exponential Fourier series coefficient here is simply given by 1 upon Ts. Okay, and because it's a 1 mark question, so we can have that knowledge based discussion here. So 1 upon Ts, where the Ts is equal to 10. So definitely the exponential Fourier series coefficient is 1 by 10. This is correct. Okay, now MSQ question, maybe more than one option is correct. So let's check the trigonometric Fourier series coefficient. Definitely A is wrong because impulse train represents the periodic waveform. Okay, periodic even symmetric waveform. Forget the periodic, it's even symmetric. That is why the Bn should be 0. Okay, but I don't say this is correct because I have to match the other two as well. Okay, now अगर trigonometric Fourier series coefficient पे आ जाएंगे C. Okay, ये तो हो गया exponential. If I come to trigonometric, okay, A naught is just as C naught, and Cn is constant 1 by 10, right? Bn will be equal to 0, right? Because of even symmetry. Because of even symmetry in the waveform. Okay, because of the even symmetry in the waveform, I hope you all are able to connect what is this impulse train. Okay, it is the even symmetric waveform. It is that even symmetric waveform. Suppose this is mt. Okay, you can put n equal to 0, you get delta t. Okay, you can put n equal to 0, there you get delta t. Okay, delta t means located at origin. Okay, then as soon as I put n equal to 1, delta t minus 10. Delta t minus 10 is located at t equal to 10. Okay, next will be t equal to 20. N ka value 2 rakha, so 2 into 10 is 20. Next will be t equal to 20. Right. Similarly, if I put n negative, n equal to minus 1, delta t plus 10. Okay, that is left shifted impulse. That is what is left shifted. Okay, then delta t plus 20. Okay, another left shifted impulse will be there, right? So this is going to be what? This is 0, this is 10, this is 20. This is what is the time period. Okay, this is minus 10, this is minus 20, and the area will be 5. The coefficient is 5 because, right? This is what is the time period Ts. Okay, and since it's 1 mark, that is why a direct question based on impulse train, which is important, where you don't have to calculate. Okay, so Bn to 0 hoga. Now coming to the An. Which is given by, right, Cn plus Cn star, or for real signal it is Cn plus C minus n, right? Yeah, this time it's a real signal only, Cn plus C minus n, right? But what is the value of Cn? 1 by 10, right? So it is constant 1 by 10, whether it is Cn or whether it is C minus n, it is 1 by 10. So this is total 2 by 10 or 1 by 5. Okay, so An is 1 by 5, yes. Bn is 0, correct. A0, the DC component, that is 1 by 10. So even the B option is correct. Okay, so the correct answer for the multiple select question, dear, is B and D. The very correct answer for this multiple select question is equal to option number B and option number D. Option number B and option number D. Moving to the next question. Okay, a discrete time signal xn is given to you, minus 1 by 3 power n un. Consider another signal yn and its z transform yz given as, okay, yz is equal to x of z power 4. Find the value of yn at n equal to 5. Find the value of the yn at n equal to 5. Yeah, just a second. Yeah, right. Okay, so yz is x of z power 4. Acha. What is x of z, dear? Okay, what is x of z as per the definition? X of z, this is 2 marks NAT question. Okay, but you know, if you apply basic properties and logic, you can solve it up quickly. X of z, the basic z transform formula, summation xn z raised to the power minus 4. Okay, from n equal to minus infinity to infinity in general. Okay, but what is yz given to you? Yz is x of z power 4. Yz is x of z power 4 and that should be, okay, x of z you know, to replace z ki jagah z power 4. So summation xn z power 4 raised to the power minus 1. Sorry, this is minus 1. Summation xn z power minus n. Okay, so here also it is minus n. Summation xn z power minus n, that is the z transform formula actually. Okay, so now this is equal to summation of xn. Okay, again the limit minus infinity to infinity. Z power 4 power minus n can be written as z power minus 4n. Z power minus 4n. Now what you can do is let 4n be some another integer m. 4n another integer m. Okay, so what is yz? Yz is summation of xn. Summation of xn. But what is n? It is going to be m by 4. Okay, summation x m by 4. And then you will have z power minus m because 4n is equal to m. Clear, everybody? Okay, and okay, whether you know, n is minus infinity to infinity, so m will also be minus infinity to infinity. Acha. Now, what is the direct formula for z transform of yn? Okay, you can also say that what should be the actual formula for yz? Yz is the z transform of yn. So that should be given by summation of yn z raised to the power minus n, and inside the summation or inside the integral, we all know the name of the variable doesn't matter. The name of the variable doesn't matter. Okay, so whether it is you know, n or m, that is okay. But if you compare these two, right, if you compare these two, you can say that y of n, if you want, I will change the name here, right? I can change the name here. This can be written as summation of x n by 4 z power minus n. The name doesn't matter. Right, so if you compare both of them, so now yn can be written as x of n by 4. Okay, and now your question is solved. That important technique is required. Now your question is solved. What is the value of yn at n equal to 5? Okay, at n equal to 5, right? That means I'm looking for y5 and use that it is equal to x of n by 4. So it is x of 5 by 4, that is equal to x of 1.25. But what is the xn given to you? It's a minus 1 by 3 power n un, and it's a discrete time signal. It will only be defined for integral values of time. Okay, and hence this is going to be 0. You can obtain the value at n equal to 1 or 2 or 0 or 1 or 2 or 3 or 4 or 5, etc. But at 1.25, it's going to be 0. It's a discrete time signal. Okay, so the answer for this question is equal to 0. The answer for the question, NAT question, the answer stands out to be 0. A good property based question. Not the property, actually fundamental definition of Z transform I can say here. Okay. Question number 8. Okay. If x of j omega is the Fourier transform of real and non-negative signal xt, and we are given the facts that f inverse, that is Fourier inverse of 1 plus j omega x j omega is k e power minus 2t ut, where k is a positive constant and integral mod of x omega square d omega is 2 pi, what is the signal xt? It's again a good question. Okay, so first of all, what is the basic information? Okay, यहाँ से आ जाते हैं. Fourier inverse of 1 plus j omega into x of j omega. Yeah, let me simply call it as x of omega. This is k e raised to the power minus 2t. Yes. Okay, so if I want to calculate 1 plus j omega into x omega, so that should be equal to what? This is inverse Fourier. Send it on the right side. That becomes the Fourier transform for, that becomes what? Fourier transform for k e power minus 2t ut, and the Fourier transform for e power minus 2t ut is given by 1 upon 2 plus j omega. Okay, e power minus 80 ut for a greater than 0, it is 1 upon a plus j omega. Right, so what is x omega? Here I get the clue about x omega, that is k is divided by 1 plus j omega into 2 plus j omega, which you can also break by partial fraction. Okay, and you can write this as 1 upon 1 plus j omega minus 1 upon 2 plus j omega, right? 2 plus j omega minus 1 plus j omega will be cancelled, and 2 minus 1 will be 1. Perfect, right? So that is what is x omega. So dear, what is xt then? If you take the inverse here, what is xt? K 1 upon 1 plus j omega e power minus t ut. 1 upon 2 plus j omega e power minus 2t ut. So ut I am writing common only. So e power minus t minus e power minus 2t ut, right? That is what is the value of xt. Okay, but the k is unknown. Okay, if they had already given the value of k, then most likely it can be a 1 marker question. Okay, now you need to find out k, okay, by using Parseval's. This is coming up as this comes up in the energy formula. So Parseval aayega, right? Okay, the Parseval's theorem will come up. So now, okay, what is the energy of the signal is given by integral of mod xt squared dt from minus infinity to infinity, and that is equal to 1 upon 2 pi integral minus infinity to infinity mod of x omega squared d omega, the basic Parseval's relation, the Parseval's energy theorem. Okay, now actually in the question you are given what is integral mod of x omega squared d omega, that is given to 2 pi. Okay, that means integral mod xt squared dt should be equal to 1. Okay, right, where xt is partially obtained, xt only k is to be found out, otherwise we know that it is e power minus t minus e raised to the power minus 2t ut. Okay, so integral mod xt squared dt, okay, from minus infinity to infinity actually will become, see, actually will become how much? K square mod of xt square, k square will be common. Okay, and outside the integral, because of ut, dear, because of the ut, I will directly write down the limit 0 to infinity, because ut is only defined for t greater than equal to 0, t greater than 0. So limit 0 to infinity. Now square isko karenge, so you can apply a minus b whole square. So e power minus 2t, this is a square, plus b square, that is e power minus 4t, right? Minus 2ab. So minus 2 into product of these two will become the e power minus 3t. Okay, dt. Okay, right, let's complete this integration, and we know that this has to be equated to 1. This has to be equated to 1. So this is equal to k e power minus 2t integral is e power minus 2t upon minus 2, then e power minus 4t upon minus 4, minus 2 e power minus 3t upon minus 3. Lower limit 0, upper limit sabhi ka infinity hai. Okay, so what I can do is definitely I can keep taking the minus outside. Okay, yeah, otherwise let it be inside only, and put down the limits on individual term. E power minus infinity everywhere, e power minus infinity will be 0. Okay, minus e power 0, e power 0 is 1, so 0 minus 1 upon minus 2. Next is equal to similarly 0 minus 1 upon minus 4, and next is minus 2, again e power minus infinity 0, e power 0 1, so 0 minus 1 upon minus 3. Okay, so how much I am getting now? How much I am getting now? This is equal to, right, k 1 by 2 plus 1 by 4, okay, minus 2 by 3, minus 2 by 3. Okay, so 2, 4, 3, I think LCM can be taken to be 12. So then this is going to be 6, and then plus 3 and minus 8. Correct? Yeah. So this becomes how much? 9 minus 8, 1. So k by 12. correct? This is what it is. Okay, sorry, k square, everywhere k square was there. Okay, so this is going to be k square into 1 by 12. Okay, so we can use k square into 1 by 12 is equal to how much, right? Is equal to, I told you, this energy should be eventually equal to 1. This should be equal to 1, right? So what is the value of k? Is going to be root 12. Okay, plus minus root 12, but if you see somewhere in the question, k is mentioned to be positive constant, and that is why root 12. Okay, so now putting the value of k, so root 12 e power minus t minus e power minus 2t. Okay, that is option number A. That is the option number A, right everybody? Okay, chalo. Okay guys, so these are my 8 questions. Hope you have enjoyed it. Hope you have learned some concepts of maths and signals from this. And as I told you, this is a mini mock. 50 marks will be covered up this particular test. Okay, in the form of MCQ, NAT, MSQ question. 10 questions are of 1 mark. 20 questions are of 2 mark, total 30 questions, 8 I have covered. And now immediately Sanjay Rathi sir, okay, you're going to see Sanjay Rathi sir, and he will be covering some questions from digital circuits as well as analog circuits. And then Ashu sir and Saket sir, everybody will join, and we are going to cover 30 questions for 50 marks in this mini mock. Once again, happiest Independence Day to all of you. Congratulations. It's 76 years of independence we have complete, and keep practicing hard, and we'll keep bringing you such sessions. Bye bye, and you'll just see Sanjay Rathi sir.
Hello everyone, happy Independence Day. तो आज आप दिन एंजॉय कर रहे होंगे. साथ में हम लोग दे रहे हैं मॉक टेस्ट फॉर गेट 2024. It is a mini mock test. Already you have solved some questions. Now it is time to solve question from what digital and what analog. So without any delay, now that is the first question from digital. Consider an 8-bit ripple adder in which each full adder takes 15 nanoseconds to generate the carry and 20 nanoseconds to generate the sum. What is the maximum rate of addition which can be obtained using this adder? That is the question. Okay, it is about what? Ripple carry adder. So how we can solve this question, ripple carry adder? So everyone please give me the answer in comments box. Yes, please try to solve this question, everyone. Your comments are not visible to me. Okay then. Now guys, it is about the ripple carry adder. 8-bit means we are having total 8 ripple carry adder like this. And so on. Okay. Then what is written here? What is the maximum rate of addition which can be obtained using this adder? So for one addition, what is the time required? We have to find. So what is the standard formula for this? Then what is the delay in one addition? That is given by n minus 1 into tau c, where n is the number of bits, tau c is the delay time for carry, and plus what? Maximum of or tau s. Which one is the maximum? Carry propagation delay or what? Sum delay. So if which one is maximum, we have to take this value. So what is the number of bit? 8. And what is the adder takes 15 nanoseconds to generate the carry and 20 nanoseconds to generate the sum. Means sum delay is more and carry delay is what? 15. Then you can use this formula, 8 minus 1 into what? 15 plus what? Maximum of 15 or 20. Which one is the maximum? 20. Then you can find 105. This is the 15 into 7 plus what? 20, and that will become what? 125 nanosecond. This is the delay. This is the delay. Then, but what is asked? What is the maximum rate of addition which can be obtained using this adder? For one addition, it is 125 nanosecond is required. Means in 1 second, we can do how many number of addition? Then simply find the reciprocal of this. The number of addition per second. That is called rate of addition. This is nothing but 1 divided by 125 nanosecond. You can write 10 to the power minus 9. And now here you can write 1000 into 10 raised to power 6 divided by 125. Yes, this is the 10 to the power minus 9 and that is 125, and you will get what? 8 into 10 raised to power 6 addition per second. Check my calculation. So this is about the first question. Hope you have got the answer. Then second one. Consider the partial implementation of a 2-bit counter using T flip-flop. Where is the T flip-flop? This is the T flip-flop, that is the T flip-flop. Following the sequence 0, 2, 3, 1, 0. So that is the sequence as shown below. To complete the circuit, the input X should be. So here the T2 it is given here. That is the nothing but Q2, Q1, an exclusive NOR of the Q2 and Q1. Q2 exclusive NOR with the Q1, that is the value of the T2. And T1 is not given. You have to find the what is the value of the what is the function for T1. And this is a synchronous counter because we are giving the same clock pulse to both the flip-flop. So it is the MSB and that is the LSB. Then how we can find the T1 and T2? Then watch this. What is the sequence here? 0, 2, 3, 1, 0. So 0, 2, 3, 1, 0 means you can write the sequence here. Q2 is the MSB, Q1 is the LSB. 0, right? 2, 3, 1, and again we will get 0. Then this is after 0, again we are getting the 2, then after 2 we are getting the 3, then after 3 we are getting the 1. So what is the present state? 0, 0. So what is the next state? This is the Qn next state. That this is represented by dash. So what is the next state? 2. 2 means what? 1, 0. What is the next state? If it is 2, then what is the next state? 3. That is 1, 1. If it is 3, then what is the next state? 1. And if it is 1, what is the next state? 0. So we can say this is the present state and that is the next state. This is the present state and that is the next state. So what is the value of the T2 and T1? Now, this is 0 to 1 means it is what? Toggle. So we don't want T2. Already we have the idea about the T2. What about the T1? 0 to 0, no change. No change means it is 0. 0 to 1, toggle. So it will switch from 0 to 1 means it is toggle. So what is the T1? Then make proper table guys here to avoid the confusion. So this is the T2 and that is the T1. Now for T1 we are writing 0 to 0, 0, 0 to 1, 1, 1 to 1, no change. 1 to 0. What is the 1 to 0? Toggle. Means what? 1. Now similarly what is the Q2? Q2 0 to 1, 1. 1 to 1, 0. 1 to 0, 1. 0 to 0, no change, 0. Now from this you can find what is the T1. We have to find the T1 here. Watch this. So write properly. When you are writing the properly Q2, Q1, 0, 0, 0, 1, 1, 0, 1, 1. That is the situation. And what is the for 0, 0? It is 0. For 0, 1, it is 1. For 1, 0, again it is 1. And for 1, 1, it is what? 0. So if that is the situation guys, this is nothing but what? X or gate. And that's why the T1 is what? XOR gate. Q1. And what is the Q2? You can find for 0, 0, it is 1, just opposite to what? T1. Right, opposite to 1. That's why T2 is what? XNOR gate. So already it is given XNOR gate T2. XNOR of Q2 and Q1. So this is the answer. Which answer is correct? D. Q1 exclusive OR with Q2. That is the value of T1. So this is the question on counter. Next one. If A exclusive OR with B, exclusive OR with AB, then simplified expression for Y is. Again that is on what? Gate, or we can say on the Boolean algebra. So A exclusive OR with B, exclusive OR with AB, then simplified expression for Y is. What is the Y? First of all, you can write AB. Everyone give me the answer in the comments box. AB 0, 0, 0, 1, 1, 0, 1, 1. Now, what is the exclusive OR of this? And what is the AND gate of this AB? Exclusive OR means 0, 0, it will become 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay, what is the AND gate? 0, 0, 0, 1. That is the AND. Then what is the exclusive OR of these two? Exclusive OR of A, exclusive OR with B, exclusive OR with A, B. Then focus on these two. 0, 0 is what? 0. 1, 0, 1. 1, 0, 1. 0, 1, 1. Now, focus on this. For 0, 0, we are getting the 0. For 0, 1, we are getting 1. For 1, 0, we are getting 1. For 1, 1, we are getting 1. It is just like what? OR gate. It is nothing but this represent OR gate. A plus B. It is equivalent to OR gate, guys. So this is the A plus B. A plus B. Okay. So ये है logic. Now second one, if that is a B exclusive OR with AB, remember B exclusive OR with AB, that is the shortcut. What we can write? B exclusive OR with AB, B A B bar plus what? B bar AB. Now guys, B bar AB what? This is 0. That will become 0. Now B A bar plus B bar. Now what you can write? B A bar, because that is 0. B B bar is 0. So this is equivalent to this term. B exclusive OR with AB. B exclusive OR with AB is equivalent to what? B A bar. Now A exclusive OR with what? B A bar or A bar B. Right? Now you have the shortcut that. So you will get the shortcut. First of all, that is the case. Second case, then A exclusive OR with A bar B. A exclusive OR with A bar B. Then you can write A bar B, the whole bar, plus A bar B. Then A exclusive OR, the bar, plus B bar, plus what? A bar is nothing but A bar B. Guys, watch this. What is this? This is what? A plus A B bar plus what? A bar B. We are getting this. Now you can use the distribution law and then again you can find the value here. So finally, by using the Boolean algebra, we are getting that, we are getting the very lengthy solution. So how we can solve this question? We can solve this question very easily by using what table? So one student asked that, sir, is it possible to solve this question by using the Boolean algebra? Just I am trying to solve that. But sometimes when we are not using the shortcut, it will become very lengthy. So simply make the table and then give the answer A plus B, guys. Next one. The next one is the Boolean function realized by the logic circuit shown is. The question is based on what? Multiplexer. What is the use of the multiplexer then? Then Boolean function is given. The function A is the mean term of this, mean term of that number, mean term of this number, mean term of that number. So there are 4 variables A, B, C and what? D. So I think it is C and D because A and B are used here. This is the C and that is the D. Now this is the inverter and that is the bar. Guys, what will be the answer? So how we are going to write here? A, B. When both are 0, 0, it will select I naught. That will become what? C. So A bar, B bar, C. That is the first term. Second, A bar B, it will select I1. So it will become A bar B. What is the I1? D. So that will select a D. Plus. Third term, A B bar. It will select I2. And what is the I2? C bar. A B bar, C bar. A, B bar, C bar. Fourth one, A, B. Right, now watch this. A, B means it will select I3. And what is the I3? C bar, D bar. C bar into D bar. That is the end. C bar, D bar. Now what are the mean terms? How we can find the mean terms? For example, this is the A bar, B bar, C. Which one is missing? D is missing. Then for this you can write 0, 0, 1, 0, 0, 1. What are the two values of the D? 0 and what 1. What is this? 2 and what is this? 3. Similarly, in case of A bar, B, D, which is missing, C is missing. Now you can write this as 0, 1, 1, 0, 1, 1. What are the two values of C? One is what? 0, one is what? 1. One is 0, one is 1. Now what is this? 5. And what is this? 7. So we are getting the mean terms 2, 3, 5, 7. Then third one is A, B bar, C bar, which is missing, D is missing. D. Now here you can use two values 1, 0, 0, 1, 0, 0. What are the two values of the D? 0 and 1. So this is what? 8 and this is 9. And finally A, B, C bar, D bar. As you know, A, B, C bar, D bar, all are present. All are present means what it is? 1, 1, 0, 0. That is nothing but 12. That is nothing but 12. Now watch. What are the mean terms present here? The function is the mean term 2, 3, 5, 7, 8, 9, 12. 2, 3, 5, 7, 8, 9, 12. Now check the answer. Check the answer. Which one is correct? 2, 3, 5, 7, 8, 9, 12 means D is the correct. 2, 3, 5, 7, 8, 9, 12. D is the correct answer. So directly write down the equation and find the function. It is of 4 variable. Okay then. Next question is a series combination of 15. Now digital over guys. Now the question from what? Analog. So try to solve these questions. Okay everyone. The series combination of 15 volt breakdown diodes and a forward bias silicon diode is to be used. Right? 15 volt breakdown diodes and forward bias silicon diode is to be used to construct a zero temperature coefficient voltage reference. The temperature coefficient of silicon diode is minus 1.7 millivolt per degree centigrade. Means what about the drop across the diode? It will change by 1.7 millivolt when the temperature increase by 1 degree, and it will decrease because it is negative. And remember, this is MSQ, multiple select question. Which answers are correct? Breakdown diode should be avalanche diode. Breakdown diode should be Zener diode. Required temperature coefficient of the breakdown diode will be this much. Required temperature coefficient of the breakdown should be 1.7. So what is the difference between this? It is given in percentage and it is given in what? Millivolt per degree centigrade. So what is asked in the question? 15 volt breakdown diode and a forward bias silicon diode is to be used to construct a zero temperature coefficient voltage reference. Means these two are connected in series. Now watch this. These two are connected in series. What is the drop here? 0.7 volt. What is the drop here? 15 volt. And you will get the output constant voltage independent of that what we are giving the input here, and that is the variable input. It will vary from minimum to maximum, but the voltage at the output will remain constant, that is the 15.7 volt, right? 15.7 volt. Okay, so we want to develop a reference voltage here, that is the, and suppose it is a 20 volt here. So 20 out of 20 there is a 15.7 and remaining the 4.3 voltage will come across the series resistance. That is called voltage regulator, just like a voltage regulator. Okay, but what is the problem? That when the temperature increases, the drop across this will decrease. So when the drop across this will decrease, it means what? Overall drop will decrease. But if it is possible that when the temperature decreases, when the temperature increases, it will decrease by minus 1.7 millivolt per degree centigrade. That is given in the question. Minus 1.7 millivolt temperature coefficient of silicon diode means this voltage will decrease by minus 1.7 millivolt per degree centigrade. Now to cancel out the effect of this, it should increase by what? Same value. So after 1 degree rise in temperature, it will reduce by 1.7 and it will increase by 1.7 millivolt per degree centigrade. Then what will happen? This is cancelled out, this cancelled out, and output will remain constant, that is the 15.7 volt. So this diode should have what? Positive temperature coefficient, right? Positive temperature coefficient means temperature increases, that value will increase, that breakdown voltage will increase, means it has PTC. And when out of Zener and out of avalanche, Zener has negative temperature coefficient and avalanche has positive temperature coefficient. And that's why we have to use what? Avalanche diode. Which one is correct? Breakdown diode should be avalanche diode. Breakdown diode should be avalanche diode. Now, what is the temperature coefficient of the breakdown diode? Should be 1.7 millivolt per degree centigrade. That is also correct. That is also correct. Yes, it should be positive and it should be 1.7 millivolt per degree centigrade. So that these two changes will cancel each other. But what is the percentage change? This is given in percentage change. So when you want to find the percentage change, remember, what is the percentage change? Always remember, you have to write like this: 1 by Vz dVz by dt into 100%. Okay. So what is the Vz? 1 by 15. What is the change? Remember, what is this? It is in percentage. This is in volt. Then 1.7 millivolt. That should convert it into what? Volt. So 1.7 into 10 raised to power minus 3 millivolt per degree centigrade. That is the dVz by dt into 100. That is the answer in percentage. So guys, it will become, this is the 100. This will become minus 10 to the power minus 1, 0.17. 0.17 divided by 15. 0.17 divided by 15. Use your calculator, everyone. Calculator. So 0.17 divided by 15. And you will get 0.0113. So 0.0113 it is given. Yes, it is correct. So guys, what is asked in the question? Whether it is in a percentage change or it is what? Direct, that is called temperature coefficient. It is not divided by the Vz. So what is the percentage change in avalanche diode? Negligible, right? And the output will remain almost constant. Both are correct. Then next question. Okay, that is the question on when we are getting the output from emitter and we are giving input to the base. So this is nothing but common collector. Input to the base, output from the emitter, and collector is common. So this is a common collector. So that, sorry, this is written here. Yeah? So you can judge from the diagram and in the question it is written. For the common collector amplifier shown in the figure, the BJT has high beta. Beta is when the beta is very, very large, we can neglect the base current. Base current is 0. Negligible VCE set, when it is in saturation, it will act as what? Short circuit, because what is the drop across from C to E? 0. Under saturation. VB 0.7 volt, it is fixed. The maximum undistorted peak to peak output voltage V0. Maximum undistorted peak to peak output voltage V0. What is possible? What is the swing of the output? It is asked. Swing, peak to peak means swing of the output. How we can find the swing? Maximum minus minimum. That is asked. This is a very, very important question. These are the coupling capacitor. To understand the swing, first of all, remove the capacitor. Just do the DC analysis. This capacitor is removed. That capacitor is removed. Now we are having this diagram. Watch this. This is the diagram. And I am going to solve this question. Now, when this capacitor is removed, for example, this capacitor is removed, this capacitor is removed. Now you can use the voltage division rule. What is the voltage here? 12 divided by, what is the Thevenin's voltage here? VTH. R2 upon R1 plus R2 into what? 12. So that will become 10 divided by 15 into 12. That will become 2. This is the 3 and that is what? 4. It is 8 volt. What is this? 8 volt is the Thevenin's. No need to find the RTH because the beta is very large, and that's why the base current is negligible. Now you can draw the diagram like this. No need to find the RTH. Why? Because the base current is negligible, 0, nearly equal to 0. Beta is very, very large. Now, what is the drop here? 0.7 volt. 0.7 volt. So, what is the output voltage under DC condition? This is what 8 volt. We are subtracting the 0.7 volt because there is no drop across this RTH. So, it will become what? 7.3 volt. So, under DC condition, what is the drop across the RE? 7.3 volt. So, how we can find the swing? So, there are two cases. First, if this is under saturation, this transistor will act as short circuit. When this transistor will act as short circuit, voltage is 0. And then in that case, this is short circuited, so this is directly connected to 12 volt. This is directly connected to 12 volt, and that's why in that case the output voltage is maximum output voltage is what? 12 volt. Maximum output voltage possible is what? 12 volt, right? When during cutoff, this is the cutoff, RE, there is no current through the RE, and that's why minimum voltage possible, DC, I am talking about the DC voltage. Minimum voltage possible is what? 0 volt, because there is no current through the RE. So what is the minimum voltage possible? Is 0 volt. Now watch this diagram. So we are having two levels. Maximum level, minimum level. Okay. So what is the maximum level? 12. What is the minimum level? 0. But where is the DC? DC is at 7.3 volt. This is the DC which is at 7.3 volt. Maximum possible DC is 12 volt, minimum possible is 0 volt, but we are giving the DC biasing at 7.3 volt, right? Already we have calculated, this is the DC biasing 7.3 volt. So how we can find the swing? Undistorted means if it is sinusoidal, guys, positive area and negative side, both should be similar. So what is this gap? 12 minus 7.3. You will get 4.7. So to maintain the shape, this should be also 4.7 only. So that we will get the proper sinusoidal signal like this. Proper sinusoidal signal like this. Undistorted output. What is the maximum swing possible? The maximum swing possible is 4.7 plus 4.7. So what is the maximum swing? 4.7 plus 4.7, that is nothing but 9.4. Okay, so that is the case. And in which case we can get the maximum. This is the maximum in this case for the given diagram. But suppose if this biasing is at what? Exactly at 6. Exactly at 6. Then what will happen? If it is exactly at 6, then we will get the maximum swing here. Maximum swing here. This is 12. This is 6. Sorry. Now, if the initial DC biasing is 6, then lowest value is 0, highest value is what? 12. DC value fixed is 0. So this is the, we are getting the maximum swing. And what is the maximum swing possible under ideal condition? 12 volt. 12 volt. But in the given diagram, we are getting the 9.4 volt. Okay, that is the answer for this question. This is a very, very good question, how to find the swing, right? Now, next question. Okay, that is on operational amplifier, guys. This is on operational amplifier, 1 mark question. In the circuit, if suppose it is the given, if it is in the exam, then definitely it is what? 1 mark question only. In the circuit given figure, LED will be on when V1 is. LED. Acha. Now we are using the concept of LED, means question is based on special diodes. Right? LED, when the LED will work? That is the good question. Right? Some students confuse that if it is work in reverse direction, then the current should flow from N side to P side. But remember, LED works in what? Forward direction. Or when the current will flow in this direction. When you want current flow in this direction, then what should be the value at this point? It should be positive. Positive. When it is positive, the diode will be forward biased and the current will flow in this direction. Then it will give the light as output. But that is the function of LED. It works in forward direction. Now, if you want positive voltage at this point, then positive terminal voltage should be greater than negative terminal voltage. It is just like a comparator. When the positive terminal voltage is greater than negative terminal voltage, so what is the value of the VA? Let the VA at this point. VA is the voltage at this point. That is nothing but output. What is the VA? Positive plus Vset. And when the VP is less than VN, means positive is less than negative, minus Vset. In that case, LED will be off. So now this is the positive terminal voltage, this is the negative terminal voltage. So what is the negative terminal voltage? It is fixed according to potential divider. The current enter into the op-amp is 0. Now, what is the voltage at this point? 12 into 10 divided by 10 plus 10. That is nothing but 6 volt. The voltage at this point is 6 volt. And when the VP is greater than 6 volt, LED will glow. So what is the answer here? In the circuit of the given, LED will on when V1 is. V1 means this one is V1. Less than 6 volt, more than 6 volt, less than 12 volt, more than. This is the more than 6 volt. Answer is what? More than 6 volt. This is the answer for this question. Next one. Okay. Again. This is again MSQ. Multiple select question. More than one answer correct. It is of 2 marks and though there is no negative marking in case of MSQ. So watch this. There are 2 ideal diodes D1 and D2. 100 kilo ohm, 100 volt, 25, 200 kilo ohm it is given. The input voltage varies linearly from 0 to 150 volt. Assume ideal diodes which are correct. Which are correct. Or it may be which are correct. In MSQ it is written. It may be one answer may be correct, 2, 3 or all 4 may be correct. Are correct. These are correct. One breakpoint at 25, second breakpoint at 100, maximum value of the output is 100. Diode D1 will never conducted throughout the time t. Throughout the time t means what? Watch this diagram. What is the input here? Varies linearly from 0 to 150. It is given in the question. Means this is the input. It is varies linearly from 0 to 150. It is a ramp function. This is the input. Okay. What is the highest value? 150. What is the lowest value? 0. Right. So this is the time. Throughout the time means when the input varies from 0 to up to this time t1 where it is 150. Right. That is the linearly vary with the time. So one breakpoint, second breakpoint, third breakpoint. How we can solve this question? Just I am giving you the hint. Then first of all, you have to make the table. Use proper approach. Once you will get the command, you can use the shortcut here. Then what is the position of the diode D1? What is the position of the diode D2? And finally, what will be the output? D2. Right? This is a question on clipper, 2-level clipper actually. It is a 2-level clipper. How we can solve this? Then Vi 0 because initial value is 0. So 0 is less than or equal to Vi. So I am saying want to say that if the Vi is 0. So Vi is 0. What is the highest battery? 100 volt. Because of that 100 volt, that diode is off. D1 is off. And because of 20 volt, 25 volt, again the D2 is also off. D2 is also off. Both are off because it is 0. 100 because of this. This is because of that 25. It is off. If both are off, what will be the output? Draw the diagram. If both the diodes are off, this is off and this is off, there is no current through this 25 kilo ohm, 200 kilo ohm resistor, and that's why the output will become 25 volt. Output will become 25 volt. Okay. Now, at this point, we are having the 25 volt. Why? Because there is no drop across 200 kilo ohm. At this point, no drop across the 10 kilo because there is no current. So, what is the voltage at this point? Vi. On this side, output 25 volt. On this side, Vi. This is the diode D2. That is the diode D1. Now, guys, when we are increasing the Vi at this point more than 0, the voltage at this point increases. When it reaches to a 25 volt, D2 will on. But to make the D1 on, we have to increase it up to what? 100. But first of all, it is linearly increases, and that's why it will increase up to what? 25. When it will increase up to 25, what will happen? D2 will on. So 25 is less than or equal to Vi is less than or equal to. This will remain off. This is on. So guys, what is the first breakpoint? 25. First breakpoint is 25. Now, what is the second diagram? Second diagram. Now, in this case, this diode is off. This diode is on. It will act as short circuit because it is an ideal diode. This is the 200. This is the 100. This is Vi. And now this is the 25. Right? So D1 is off, D2 is on now for more than 25. Then first of all, find the V0. To find the V0, this is the voltage V0. You can apply the KCL. V0 minus Vi upon 100, V0 minus 25 upon 200, V0 minus Vi upon 100 plus V0 minus 25 upon 200 is equal to what? 0. You can take 200 as a LCM. So it will become 2V0 minus 2Vi plus V0 minus 25 is equal to 0 upon 200. We are taking the 200 as a LCM. Then from that, please watch the equation carefully. You will get 3V0 minus 2Vi is equal to what? 25. So what is the V0 is equal to 2 by 3 Vi plus 25 by 3. 2 by 3 Vi plus 25 by 3, that is for the second case. 25 by 3. Now this is the output. But what is the breakpoint? How we can find the breakpoint? Once the output is known, check the diode D1. Because already it is on. No need to check the D2. On the negative side, 100 volt is given. On the positive side, we are having the V0. And when the V0 is greater than 100 volt, then the diode D1 will conduct. Then guys, what we are doing? Right, watch this. Third diagram. Watch this. So already we have the output when this V0 is greater than 100 volt. Means 2 by 3 Vi plus 25 by 3 greater than or equal to 100 volt. D1 will conduct or D1 will on when positive terminal is greater than negative terminal. Solve it from this 3 it will become 300. 2 Vi plus 25 is greater than 300 plus 300 275. So what is the Vi will become greater than or equal to 275 divided by 2. And you will get 137.5 volt. Please check my calculation. That is the value. So when the input is greater than 137.5 volt, then what will happen? 37.5 volt is the drop across the 100 kilo ohm, and then at that point 100 volt will become, once it will become 100 volt, diode D1 will on. So what is the next break point? That is very, very important about this question. 25 is less than or equal to Vi is less than 137.5 volt. So guys, this is the second breakpoint. Okay, 137.5. So 137.5 is greater than or equal to Vi is greater than or equal to what? 150. Last value. What about the D1? On. What about the D2? On. When both the diodes are on, that is on, this is on, then what will be the circuit? If both the diodes are on, then this will become short circuit. This diode is on, 25 volt, 200 kilo ohm, 100 kilo ohm, Vi. Once both the diodes are on, output, this is parallel, this is the 100 volt. So it is fixed at 100 volt. What is the maximum value of the output voltage? 100 volt. It will remain constant. We are increasing the input from 137.5 to what? 150 volt. That will remain 100 volt. What is the highest value of the input? 100 volt. And that what? D1 will conduct when the input is greater than 137.5. D2 will also conduct when the input is 25. So which answers are correct? In MSQ you have to check each and everything. One breakpoint is at 25, correct. Second breakpoint is 100, wrong, because second breakpoint was 137.5. Maximum value of the output is 100, right. Diode D1 will never conduct, wrong, throughout the time. Which are correct? A and C. So this is the MSQ. Question number 16. Okay, then next question. Now 17. Using the incremental low frequency small signal model of the MOS device, the Norton equivalent resistance of the following circuit is. That circuit is given, everyone. Please try to solve this question. Okay, then what will be the answer for this one? Yes, tell me, what is the answer for this question? Using the incremental low frequency small signal model of the MOS device, the Norton equivalent resistance of the following circuit is. This is what? Norton equivalent means what? We are giving the input at this point and we have to find the Norton's equivalent at this time. Just like a Thevenin's resistance or Norton's resistance. So this is our, just we have removed the load, means we are taking the output from the source. This is the drain terminal, that is the gate terminal. If suppose you are going to get the output from the source terminal, means we can say it is just a diagram, what common drain configuration. Now how we can solve this question and how we can find what is the Norton's equivalent resistance? So first of all, draw the model and then we can find the value. So how we can draw the model here? A small signal model. I am talking about the small signal model. What is the model here? GMVGS. Everyone, if you have the idea about the answer, then please comments. Because answer it is given RDS and GM. GM is the trans conduction and RDS is drain to source resistance because of early effect or channel length modulation. This source terminal is open. This is the gate terminal. Under DC analysis, that VDD will become 0. This is, we are doing the AC analysis and gate is already 0. Now here the gate is connected toward ground. This is the source terminal and here we are taking the, we have to find the Norton's resistance here. Draw the model, then watch this. This gate is connected to ground. So you can make a common ground here, right? This gate is connected to ground. Okay, no problem. Now this voltage from this point to this point, this is plus, this is minus, this is called VGS, because it is depends upon the VGS, and this is the RDS, and this resistor is what? R, and VDD is 0. VDD is 0 means this R is connected toward ground. You can draw the circuit. This is connected to ground. This is the R. Okay. Now this is the GMVGS. Now watch this. If you want to find the resistor across this, then you have to connect a 1 volt battery. So I am just changing the color. Here you have to connect a 1 volt battery here, plus minus 1 volt battery, and it will give the current I. That is the rule to find the Norton's resistance. So what is the Norton's resistance will become Rn is equal to 1 upon I. You have to find this 1 upon I. Okay. Then first of all, this is I, this is GMVGS. So what will be the current here? I plus GMVGS. Now at this point, what is the current going here? GMVGS. What will be the current? Again I. We are applying the KCL at this point. What is the incoming current? GMVGS. What is the incoming current? I. So what is the outgoing current? I plus GMVGS. That will pass through that, and this is the output. And now it will move like this. Now you can write the KVL from this point to this point. From, sorry, चलिए color कुछ use करें दूसरा. Yes. This point to this point to this point, we can write a KVL. Right? When we are writing the KVL, then you will get one equation. -1 plus I plus GMVGS into what? RDS plus I into R, and again it will become 0. Now from this equation you have to find what? 1 by I. For what is the RTH? 1 by I. But which one is the villain? VGS. How we can remove the VGS from this equation? So this is the first equation. So you can remove the VGS. You have to write the 1 KVL here. Where 1 KVL? To write 1 KVL in this loop. This is the 1 KVL. When we are writing 1 KVL here, you will get plus VGS plus 1 volt is equal to 0. VGS plus 1 volt is equal to 0. So what is the VGS is equal to? -1 volt. VGS is equal to what? -1 volt. This is the equation number 2. Put 2 in 1. Put 2 in 1. Then what will be the equation, guys? Equation will become, what is the equation? -1. 1 minute. Plus I plus GM. What is the VGS? -1 into RDS. Okay, into RDS plus IR is equal to what? 0. Right. Okay. Now open the bracket. -1 plus I RDS plus IR minus GM RDS is equal to 0. Then IR plus RDS is equal to 1 plus GM RDS. Okay. Then guys, what is the 1 by I? From this 1 by I is equal to R plus RDS upon 1 plus GM RDS. And that is called resistance. That is called Norton's resistance or Thevenin's resistance. R plus RDS. So which answer is correct? R plus RDS upon 1 plus GM RDS. That B answer is correct. So we are using the concept of what? Thevenin's or Norton's equivalent from the network, and this is the standard formula for what? Output resistance of common drain configuration, and that is very small because this is divided by what? 1 plus GM RDS, and this is a very high quantity. So normally in case of what? Common drain, the output resistance, just like a common collector, low. So we are getting the low output resistance. So this is about digital and analog question. Guys, so happy Independence Day. Thank you for solving the question, but stay tuned with us. Try to solve the remaining questions. Again, happy Independence Day.
हेलो एवरीवन एंड थैंक यू संजय सर. सो गाइस, आपने 17th क्वेश्चन तक डिस्कस किया है. सो लेट्स स्टार्ट फ्रॉम क्वेश्चन नंबर 18th. Now I will discuss network theory and control system with you. But before that, it's a 77th Independence Day for us. So today it's a historical day, 15th of August. So we got freedom from British Empire. Okay, so आज के दिन हमें कुछ चीजों से free होना है. Like which things are demotivating you. So you have to find out those things and then आप उनसे डीमोटिवेट अगर है तो उनसे कैसे दूर हो वो चीज आप देखिए और उसके ऊपर वर्क कीजिए, कंसेप्चुअल अंडरस्टैंडिंग बनाइए, प्रैक्टिस ज्यादा से ज्यादा कीजिए सो दैट आप फ्री हो सके उन सब चीजों से. Excuse me. So guys, let's start today's session. So this is question number 18 and the marking scheme is not given. So this is a 1 mark question. Okay, this is 1 mark question. So let's start with that. So you have an infinite ladder of capacitances. You can see that. Now we need to calculate the equivalent capacitance between A and B. So it's a 1 mark question. How to do that? It's very simple. What you can do is first you identify the repeating branch. The repeating, you can say repeating branch. Yes. So what you can do is you can see that this C and this C, they are repeating again and again. Okay. They are repeating again and again. You can see that. C and then C and then C, okay? So they are repeating again and again. So what you can do is, you can skip this first one, okay? And if you remove this, then the equivalent capacitance of this entire ladder is again the same, okay? The equivalent capacitance of this entire ladder is again the same. Because if you are removing the first part, okay, it will not affect because it's an infinite ladder. So in an infinite ladder, if you remove that first part of the ladder, the equivalent capacitance will not change because it's huge, it's up to infinite, okay? So it will not affect the equivalent capacitance. If I remove it, then this ladder will be left behind and the equivalent capacitance of this ladder and this ladder will be same. Let's assume that the equivalent capacitance is C equivalent. Between A and B, the equivalent capacitance is C equivalent. Now what I'm doing is, I am removing this first circuit, C and this C. After removing, you have this ladder. And we know that if the equivalent capacitance between A and B is C equivalent, between this A and B, if the equivalent capacitance is C equivalent, after removing this first circuit, the equivalent capacitance of this entire ladder is again C equivalent. So let's replace it with C equivalent. Okay? This is C, this is C, this is C equivalent, and this will also be C equivalent. I need to calculate this C equivalent value. So how to calculate this C equivalent value, guys? It's very simple now. What you can do is you can take them in series and then this is in parallel. So if I take them in series, it will be C into C equivalent divided by C plus C equivalent. This is the series equivalent of these two capacitances. In parallel with C, so I have added this C, and this combination has to be equal to C equivalent, okay? So from here you can calculate the C equivalent value and you can check which option is correct. So let's calculate it. So take the C on the other side. So C into C equivalent is equal to C equivalent minus C into C equivalent minus C. I have taken the C on this other side into C equivalent plus C. C equivalent plus C. Okay. Now if I simplify this, it will become C equivalent square. Okay, let me simplify it. So it will become C equivalent square minus C square is equal to C equivalent square minus C square is equal to C into C equivalent. Okay, take the C equivalent on the other side. So it will become C equivalent square minus C into C equivalent minus C square equal to 0. Okay. Now from here you can calculate the C equivalent value. It's a quadratic equation. So if this is the quadratic equation, then the solution for this is C equivalent will be equal to minus B plus minus root of B square minus 4AC. So it will become 5C square divided by 2A. Divided by 2. Now you can see that this will become C into 1 plus root 5 by 2. Why I am not taking minus? Because C equivalent cannot be negative. And if you take minus, it will become, it will give you the negative answer. Okay, so if you take positive answer here and if you calculate this, so you will get this value. This is my C equivalent. So the answer is Delhi. Answer is Delhi. So question is very simple, and I hope you all guys have solved it. It's a 1 mark question. Now let's come to the next question. It's a 2 mark question, guys. It's a 2 mark question. Okay, so let's see what this question says. If the circuit shown, in the circuit shown, if the power consumed by this 5 ohm resistor is 10 watt, okay, this is the power consumed by this resistor, okay, then the power factor of the circuit, I need to calculate what is the power factor of the circuit. So if you know that the power consumed by this 5 ohm is 10 watt, then you can calculate the current. Okay, current is I RMS square into R, that is equal to, so I has to be root 2. I has to be, this is the RMS value of the current. So we found the RMS value of the current. Now we know that if I calculate the RMS current with the help of impedance, then that current will be voltage RMS value, that is 50 by root 2, divide by voltage divided by magnitude of the impedance, and the magnitude of impedance is root of 15 square plus XL square. Okay, this is the RMS current in the circuit. Voltage RMS divided by the impedance value. Impedance is 15 plus j omega L, means jx, and I have taken the magnitude. Okay, so this will give you the RMS value of the current, which is root 2. Okay, now from here you can see that it will become 2 into root of 225 plus XL square will be equal to 50. Okay, you can easily see that root 2 into root 2 is 2, and I have taken this root quantity on this side and 50 is on this side. Now I can square on both sides. So if you square on both sides, you will get 4 into 225 plus XL square is equal to square of this 50, that is 2500. Okay, now what you can do is you can calculate XL from here. XL equal to 2500 by 4 minus 225 and take the root of that. Okay, so this is my XL. Now you can calculate this XL value. Let me simplify this. Okay, so it will become 2500 minus, if you multiply it, I think it will be 900. Okay, so 900 by 4. Now if 2500 minus 900, you will get 1600 divided by 4. So you will get a root of 400, and root of 400 is 20. It means this is J20. Okay, this is J20. Now we need to calculate the power factor. We know that the total impedance is equal to a real part plus imaginary part. And we know that the impedance angle will be the power factor angle. The impedance angle will be the power factor angle. So what you can do is you can calculate, or directly you can calculate cos phi from here. Cos theta z. Cos theta z is the power factor. And what is theta z? Theta z is the impedance angle. Okay, so you can write it like this. The 15 is the real part, 20 is the imaginary part. Okay, and this is my theta z. This is 15, this is 20. So this will become 25. Okay, you can apply Pythagoras. Now what is cos theta z? Cos theta z is 15 upon 25. Okay, so it will become 15 upon 25, and now you can cancel with 5. So this is 3, 5, so this is 0.6. Okay, so power factor is 0.6 lagging. Answer is Bombay. So this was a very good question, and I hope you all guys have understood it. Let's come to the next question. Question number 20 on your screen. You can see that it's again 2 mark question. Okay, it's again 2 mark question. Now the question is the terminal volt ampere condition of a linear reciprocal network N are shown in the figure A. So this is our figure A, and it is given that if you apply 12 volt here, this current is 4 ampere and this current is 2 ampere. Now what is the current I in the corresponding to the terminal condition shown in the figure B? Okay, so same network is reconnected. Okay, and you can see that in this question I need to calculate this current I. Now how to calculate? So what I need to do is I need to apply a reciprocity plus superposition on this circuit. With the help of reciprocity and superposition, we can calculate this. So let's try it. First, let's deactivate this source. if I deactivate this source, the circuit will look like this. The circuit will look like this. This is 30. Okay, this is 30 and this is short circuited. And we need to calculate this current. Let's call it I1 due to this 30 volt only. What is this current I1? We have deactivated this source. This current I1, you can calculate from here. You can see that if this is 12 volt, then this current has to be 4 ampere. If this is 12, this has to be 4 ampere. So you can apply homogeneity here. At 12 ampere, at 12 volt, the current is 4 ampere. And if the voltage is 30, then the current will be 4 by 12 into 30. Okay. So it came out to be 10. It means this current is 10 ampere. We found that due to this 30 volt, this current is 10 ampere. Okay. Fine. Now what we can do is, now you can deactivate this source and take this source. So the circuit will look like this. So what I have done is, I have deactivated this 30 and connected a 6 volt here. Look at the polarity of this 6 volt. Okay. And we want to find this current. Let's call it I2. Let's call it I2. What is this current? So again, we can calculate this current using reciprocity. We can apply reciprocity here and calculate this current I2. If you apply reciprocity, you can see that in this circuit, if I apply reciprocity, the circuit will look like this. This 12 will go on the other side. Here you have 12 volt. Okay, and you can deactivate here. Okay, so I have taken this 12 volt on the other side and I have deactivated this side. So this current will go on this side. Okay, this current will become 2 ampere in downward direction. So for 12 volt of this polarity, this current will be downward. If I change the polarity of this 12 volt, this current will be inward. Okay, so if I do it like this on the same circuit, if I revert the polarity of this 12, this current will become inward. Okay, 2 ampere. But the problem is we don't have 12 volt, we have 6 volt. So because of the 6 volt, the inward current came out to be 1 ampere. Inward current came out to be 1 ampere. Okay. So for 30 volt, this inward current is 10 ampere. For 6 volt, this inward current is 1 ampere. And if you are applying both the sources, then you can apply superposition. This current will become 11 ampere. So the answer is 11 ampere. I hope you got it. Okay. So this was again a simple question based on reciprocity and homogeneity. Okay. Let's come to the next question, guys. This is the next question. Again, it's a 2-mark question. It's a 2-mark question. So let's look at this. In the circuit shown below, the switch is closed at t equal to 0. Okay, at t equal to 0, we are closing the switch. What is the initial value of the current through the capacitor? Okay, it means we need to calculate this current at 0 plus. Okay, how to calculate this current? It's simple question, guys. First of all, the switch was open for a long time. If the switch was open for a long time, so this circuit, after opening this, if the switch was open, this circuit will be under steady state. And under steady state, this will be shorted and this will be open circuited. Okay. So the entire current was flowing like this because it is short circuited and it is open circuited. So the entire current was flowing like this. And how much current was flowing? 12 divided by 3, 4 ampere. Okay. So this is 4 ampere and which is flowing like this. Through this inductor, 4 ampere is going downward. Okay. Through this inductor, 4 ampere is going downward. I hope it is clear, everyone. Okay. 4 ampere is going downward. Now, 4 ampere is going downward and it will behave like short circuit. And you know that since it is behaving like short circuit, so across this resistance, you have 4 volt and this 4 volt is available here. Because this point and this point has the same potential. If you are assuming that this is 0, then this point will also be 0 because the inductor will behave like short circuited. So you have 4 volt across this 1 ohm and the same voltage is available here. Here also you are getting the 4 volt and there is no current on this direction. Why? Why there is no current? Because the capacitor will behave like open circuited. The capacitor will behave like open circuited before t equal to 0. Okay. It means whatever voltage here you have, the entire voltage will be across capacitor C. Because there is no current. If there is no current, there is no voltage across the resistor. So whatever this total voltage, that voltage will come across this. Okay. It means before t equal to 0, this is the circuit we have. Okay. Before t equal to 0, this is the circuit we have. Okay. Before t equal to 0, for t less than 0, we have drawn the circuit. And this current is 4 ampere. This current is flowing as 4 ampere. This inductor current is also 4 ampere. This capacitor is charged at 4 volt. and it is open circuited, okay, and it is short circuited. Now what I'm doing is I'm closing the switch. Now if you are closing the switch, how the circuit will look like, okay? So after t greater than 0, after t greater than 0, let's see how the circuit will look like. So we have 2 ohm, this is our 2 ohm, okay, and we have this 1 ohm, this is 1 ohm, and this is also 1 ohm, okay, this is 1 ohm, this is 1 ohm, and we have closed this switch. And this inductor will behave like a current source, and this capacitor will behave like a voltage source at t equal to 0 plus. I'm drawing the circuit at 0 plus. Just after closing the switch, this circuit will work, okay? This current is 4 ampere, inductor will behave like current source at t equal to 0 plus, and it will behave like voltage source at t equal to 0 plus. And this voltage is 12 volt. This voltage is 12 volt. Fine. Now we need to find this current at t equal to 0 plus. So this circuit is working at t equal to 0 plus. We need to calculate this current. How to calculate? It's very simple. You can assume that this is grounded. If it is grounded, this has to be at 4 volt. This has to be at 4 volt because from 0 to 4. Okay, so this point is at 4 volt. Now, if this is 4 volt and this is 12 volt, can you calculate how much current will flow from here? And how much current is going in this direction? And how much current is going in this direction? If somehow we can calculate that, we can easily calculate this current. How to do that? We can apply nodal. Let's assume that this voltage to be VA. Let's assume this voltage to be VA. If I apply nodal, because we have to calculate VA, then only we will be able to find this current and this current. Okay, so the coefficient of VA is 1 by 2 plus 1 by 1 plus 1 by 1. 1 by 2 plus 1 by 1 plus 1 by 1 is equal to entering current. And what is the entering current? 12 by 2, that is 6. Plus here the voltage is 4. So 4 by 1 is entering current. So 4 by 1 is 4 and 4 by 1 again 4. I hope you understood it. Okay. So now you can see that VA, and it is 2.5, that will be equal to 14. This will be 14. Okay. This will be 14. So we found this voltage to be 14 divided by 2.5. Okay. So VA came out to be 14 divided by 2.5. Now, if this voltage is 14 divided by 2.5 and this voltage is 4, how much current will go on this side and how much current will go on this side? It's very simple. 14 divided by 2.5 minus 4 divided by 1. So, 14 upon 2.5 minus 4, this is the 4 volt, divided by 1. No need to divide by 1 because 1, if you divide it 1, it's same thing. Okay. So, you'll get 4 divided by 2.5. It means this current is 4 divided by 2.5. This current is also 4 divided by 2.5. Okay. Now, what is this 4 divided by 2.5? Let's calculate in decimal. So, if you calculate this in decimal, this is 40 by 25. 1.6. Okay. So, this current is 1.6 ampere, but this current is 4 ampere. If this is 1.6 and this is 4, then how much current will come from this side? 4 minus 1.6. So 4 minus 1.6 is 2.4 ampere. It means this current has to be 2.4 ampere. If this current is 2.4 and this current is 1.6 again, 1.6 ampere is coming from the above side. This current is going to be 2.4. Then how much current this capacitor has to supply? It means this capacitor will supply the current. It will not take the current in downward direction. It has to supply 2.4 minus 1.6, that is 0.8. So 0.8 ampere will go through the capacitor in upward direction. In upward direction, 0.8 ampere will flow. Direction is not mentioned, only the magnitude is asked. So answer is Agra. Okay. So this was again a very beautiful question of 2 marks, and I hope you understood it. Let's come to the control system now. Okay. So this is the first question of control system, question number 22nd. The question on your screen is the gain phase plot of a linear control system is shown below in the figure. What is the gain margin and the phase margin of the system? So we need to calculate the gain margin and the phase margin. So first of all, if you look at this circuit carefully, at this point you are getting 0 dB. Magnitude is 0 dB. So we call it omega GC. This is omega GC. Okay, this is omega GC. And at this point, the phase is minus 180. So we call it omega PC, phase crossover frequency. Omega PC. Now you can see that at omega GC, angle of GJ omega, HJ omega is less than minus 180. Almost, you can take it minus 200 roughly. Let's take it minus 200. I'm taking it roughly. Okay. Now what is the phase margin? So phase margin is this angle plus 180. So phase margin is negative. You are getting negative phase margin. Okay. So the phase margin has to be negative. Now you can see that phase margin greater than 0, less than 0. So either B is correct or D is correct. A and C are wrong. Now let's come to the gain margin. You can see that at this frequency, at omega PC, the magnitude is positive. If you remember in the polar plot, from the polar plot, you can see that, let's say this is the polar plot. Let's assume that this is the polar plot and this is our omega PC, phase crossover frequency. At phase crossover frequency, we look at this A. Actual value is A, but in dB, it is 20 log A. 20 log A. This much of dB. Now, what is the gain margin? So the gain margin is 0 dB minus this 20 log A dB. This is my gain margin. 0 dB you can write at 20 log 1. Y minus 20 log A. This is our gain margin. So you can calculate that this is 20 log 1 by A. This is the formula for gain margin and it came from this. It means the gain margin has to be 0 dB minus the dB gain at omega PC. Now you can see that at omega PC the dB gain is positive. The dB gain is positive. This is positive. And 0 dB minus this positive value, so you will get gain margin to be negative. Okay, so gain margin is also negative and phase margin is also negative. Answer is Delhi. Okay, so this was 1 mark question. Okay, this was 1 mark question and I hope you understood it. Okay, let's come to the next question, guys. The next question on your screen is question number 23. The open loop transfer function GSHS of a Bode plot shown in the figure. Okay, so we need to calculate which option is correct, which option is representing the correct transfer function. Now it is very interesting because you can see that in all the options, all the transfer functions are non-minimum phase system. Okay, excuse me, minimum phase system. Now it means by default you have to answer the minimum phase system. So let's calculate it. So we know that at starting it's minus 20 dB per decade. So in the denominator there must be S term. Now you can see that in this option there is no S term, in this option there is no S term. So in denominator you must have S term. Now at omega equal to 2, slope got decreased, further decreased. It means this S by 2 plus 1 has to be in the denominator. So you can see that in the denominator there must be S plus 2 term. If you take LCM, then S plus 2 terms, so this cannot be correct because there is S plus 20. We need S plus 2 term in the denominator. Now at this point you can see that slope is increasing. So this has to be in the numerator, S by 20 plus 1. Okay, into K. This will be the transfer function of this system. Now you can see that if you simplify it, so this option will satisfy. Okay, if you take LCM and you take this numerical value in this K. Okay, take this 1 by 20 and 1 by 2 in this K. Okay, you can take common now, this 1 by 20 and 1 by 2 and then you merge into this K. So the function will look like this. Okay, so I hope the answer is Bombay. This was 2 mark question. It's an easy question. Okay, let's come to the next question, guys. The next question and the last question from control system is this. Consider the system with this GS is given, HS is given, the breakaway points of the root loci are. So we need to calculate the breakaway points. how to calculate the breakaway point? It's very simple. First of all, GSHS is given as this value. Okay, if I show the zeros and poles, so you can see that the zeros and the pole location will be, let me use different color. Okay, so first of all, zeros is at -2, -1 and -2. This is our 0. And what is the pole location? If you calculate the pole location from here, so minus b plus minus root of b square is 4, minus 4ac divided by 2a. So you'll get -1 plus minus, it will become -8, 2 root 2, so 2 is cancelled, j root 2. Okay, so the pole location is, real part is -1 and the imaginary part is root 2. There are two pole locations. These are the pole location, and this is our 0 location. So which part of the root locus will, which part of the real axis will lie on the root locus? You can see that this part of the real axis will lie on the root locus, and this part of the root locus will lie on the root, this part of the real axis will lie on the root locus. Okay, I hope it is clear. What about this part? This part will not lie on the root locus. Okay, and excuse me, I made a mistake. This part will also not lie on the root locus. Okay, only this part of the real axis will lie on the root locus. Perfect. Now what will happen? Obviously, if you increase the value of k, they will come like this. Okay, they will meet somewhere and then they will go. So this point is known as break-in point. So we have to calculate this break-in point, and this break-in point has to be less than -2. So it cannot be correct. Okay, and there will only be one breakaway point, a break-in point. There is no breakaway point in this graph. If you look at this carefully, there is no breakaway point. So breakaway point is not there. This will also be cancelled because there are no 2 points, only 1 point is there. Okay, there is only 1 point. There is no breakaway point, and there is one more point. I mean, out of these two, we have to check. This is break-in point, it's not breakaway point. Okay, so let's see which option is correct. So what you can do is, how to calculate this point? We know that this is GSHS. So we know that GSHS equal to -1, you can calculate the k value. So k will be equal to minus of, tell me guys, s square plus 2s plus 3 divided by s plus 2. Now what we can do is, we can take the derivative and calculate the breakaway point. Dk by ds will be equal to 0. If I do like this, then in the denominator it's the square, and in the numerator you will have s plus 2 into the derivative of this. Minus is outside, no? Minus is taken outside. S plus 2 into derivative of this is 2s plus 2 minus, tell me guys, minus s square plus 2s plus 3. Okay, and put it equal to 0. So if you put it, this quantity equal to 0, this denominator is gone. In the numerator you will have 2s square. If I multiply this with this, 2s square plus 4s plus 2s, so 6s plus 4. Okay, it will become 2s square plus 4s plus 2s, that is 6s plus 4, minus s square minus 2s minus 3 is equal to 0. Now if you simplify it, it will become s square plus 4s, s square plus 4s, s square plus 4s plus 1 is equal to 0. Okay, now if you calculate, you will get minus b plus minus root of b square minus 4ac. 16 minus 4 divided by 2. So you will get minus 4 plus minus 12. 12 is 2 root 3 divided by 2. So you will get minus 2 plus root 3 minus 2 minus root 3. So there are 2 points, and this point has to be the break-in point. Minus 2 minus root 3. This is the break-in point, and this must be breakaway point. But this is breakaway point, but it is not for k greater than 0, because if you are moving k positive, this is k0, and if you are increasing the k value, then there is only break-in point for positive value of k. It doesn't mean that the breakaway doesn't exist. Breakaway exists, but breakaway is for negative value of k. If you plot the counter root locus, in the counter root locus, you will see that you will see that if you increase the k value from minus infinity to 0, then this will be the root locus, okay, the counter root locus, and this point is the breakaway point, okay. This point is the breakaway point because it is not mentioned about whether k is positive or negative. It means this is not correct. There is no breakaway. Yes, there is a breakaway point, but for negative value of k, there is a breakaway point, okay. So we need to calculate the breakaway point of the root locus. So breakaway point is this point. Breakaway point is this point. And what is this point, guys? What is this point, guys? This point is this value, okay, minus 2 plus 1.7. So the answer is this. Agra is the correct answer, okay. Agra is the correct answer. There will be breakaway point. There will be breakaway point for negative value of k. For positive value of k, break-in point will exist, not the breakaway point, okay. So the answer is Agra. This is not correct. This is not correct. Answer is Agra. There will be breakaway point. If you look at the counter root locus, then you will see that there is a breakaway point and there is break-in point for positive value of k. But it is not mentioned about k, whether k is positive or negative. It is not given, okay. It is written that root loci. Root loci doesn't mean that k is not positive or negative. K can be positive or negative, both, okay. So guys, this was the last question from my side. Now from this point onwards, Saket sir will continue and Saket sir will join, okay. So again, congratulations guys, and don't forget to subscribe our channel, subscribe it, like this session, and press the bell icon so that you get the notification whenever my sessions are live. So I welcome Saket sir from this point onward. Thank you.
Hello everyone, welcome to BYJU'S exam prep. Before starting the question number 25, I would like to wish you the happy Independence Day. So this is our 77th Independence Day, and here we are celebrating with all of you with the GATE mini mock test, where you can check your score, that how much you are scoring, and it is about covering all the 50 marks. Out of 100, we are actually targeting the 50 marks. If you score according to 50 marks, then you can just proportionate to it with the 100 marks, because we have covered all the common subjects. Okay, so according to that, you can calculate your overall number out of 50. Okay, so because in this particular session, I have covered the questions which is common for both the electrical and electronics, and I am covering the subject electromagnetic field theory. So obviously the common part for both the branches, and in fact the instrumentation branches, is electricity and magnetism, or you can say the electrostatic and magnetostatic. Right, so I am going to cover all the 5 questions from these 2 topics. So just prepare with these 5 questions or 6 questions from this subject. And if you are an electronics student and you have not studied this part, then learn it from the question, because it is equally important for you. Maybe it is less chance to come in the GATE, but if you are preparing other exams, then definitely you will see the question from this topic. So coming to the question number 25. So 2 regions are separated by a current sheet with the K is equal to 4.5 AZ ampere per meter at Y equal to 0. And the magnetic field in the region Y less than 0 is H1 equal to 4AX plus 5AY plus 7AZ ampere per meter. In the first medium, we have the relative permeability 2, and the second medium, we have the relative permeability 5. Then you have to calculate the value of B in the second medium. Okay, so as you can see that there are 2 regions. So before starting the session, I would like to say that you have to pause the video, and clearly what you can do is you can solve by your own, and then you check the answer with my solution. Okay, so I'm waiting for you guys to solve, and just do it within 1, 2, 3, 4, and 5. I hope that you have done it, and now I am solving, so you can check the solution. So in this question we have H1. Okay, so this is H1. We have H1, which is equal to 4AX plus 5AY plus 7AZ, 4AX plus 5AY plus 7AZ. Okay, this is in the medium 1, which is Y equal to 0 is the boundary, and y less than 0 we have the medium 1, and y greater than 0 we have the medium 2. We want to calculate the B2 in the second medium. The permeability in the first medium is 2 and the permeability in the second medium is 5. Okay, and the current is given in this question. It is in the positive z direction. So let us say this is the positive z direction. So the value which is given is 4.5 AZ. So 4.5 AZ. Now to solve this problem, first of all you have to apply the boundary condition, because we know that whenever there is a two medium and they are separated by some boundary, then definitely this has to satisfy the boundary condition. And here you can easily say that the normal component of magnetic flux density in both the mediums are equal. So in the first medium, what will be the normal component? The normal component will be the y component. So this is 5 into, this is h. So b is equal to mu h. So this is mu 1. That is giving you Bn2. So we have the answers in this form. It is ampere per meter written. So that means they are asking for the H2 only. So no need to calculate this. You can put it in this form. Okay, let's write in this form. That is mu 1 H and 1 is equal to mu 2 H and 2. So mu 1 is mu naught into 2, and H and 1 is 5, and mu 2 is 5, and H and 2 is we want to calculate. So and also mu naught. So this mu naught and mu naught will get cancelled, 5 and 5 will get cancelled. So the normal component is 2. So the normal component of the second medium will be 2. So we have the two options with the normal component 2. So that means these two options are eliminated. So now our answer will be either C or D. Now coming to the second boundary condition, this was the first boundary condition that we applied. The second boundary condition says H1 minus H2, and especially the tangential component of medium 1 and tangential component of medium 2, cross product with A and 1, 2 is equal to the K. So HT1 means the tangential component of the first medium, which is 4AX plus 7AZ, and minus HT2 we want to calculate. So let us say H2X AX and H2Y AY AZ, H2Z AZ. So H2Z, because the Z component we will get what are the tangential component, X component and Z component. So in the second medium, the Z component I am writing H2AZ. Okay, and this whole term will be cross product with the A and 1, 2. From medium 1 to medium 2, when we are going in the positive y direction, and this is 4.5 AZ. Now if I take the cross product, AX cross AY is AZ, so we will get 4 AZ, and 7 AY, AZ cross AY we will get minus AX, so minus 7 AX. When you perform this AX cross AY, you will get minus H2X AZ, and this is minus H2Z. This is again Z cross Y, that means negative X, so this will become positive AX, and here we are going to get 4.AZ. So when you compare the Z component, you will see that you are getting H2Z AX cap minus H2X AZ cap. It is equal to 0.5 AZ cap and 7 AX cap. So on comparing the X component, you can see that this is the value you are getting, and when you compare the Z value, you get. So H2Z, that means the Z component of the second medium, you are getting as 7, and the X component in the second medium you are getting minus 0.5. So overall field will be H2 is equal to the X component, which is minus 0.5 into the unit vector, plus Y component was the normal component, the magnitude was 2, so 2AY. The Z component is 7, and this is AZ. So this will be our answer. So minus 0.25, yes, answer is option number C. So correct answer you will get option C. So those who have got the 7 option C can add these 2 marks in their total score. Okay, now coming to the second question, because it is the common part. So we have some question from the vector calculus as well. Two magnetic fields are given as B1 is equal to x ax minus y ay plus z minus y az, and B2 is equal to e to the power minus y cos x ax plus sin x ay. The correct option is whether it is a solenoid or not, you have to tell. So to check that, what you have to do, just you can comment in the comment section, but I am waiting for the 10 seconds. So just pause the video and answer this question and then check the answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm expecting that you have paused the video and you have solved it. So let's calculate the solenoidal condition. So for a vector to be solenoid, what is the condition? For a vector to be solenoid, the condition is the divergence of the vector should be 0. Okay, if it is solenoid, then it is 0. So we will calculate for B. So wait, yeah, so we will calculate for B1. So let me write the B1 first. X y x ax minus y ay and z minus y az. Okay, so now divergence of B1. The divergence of B1 is when we will differentiate it with respect to x. Let me write the equation once. So del By upon del y and del Bz upon del z. This is the formula. So now the divergence of B1 is when we differentiate with respect to x, we will get 1, plus when we differentiate with respect to y, we will get minus 1, and when we differentiate with respect to z, we will get 1 again. So it is not equal to 0. So the divergence of the B1 is not equal to 0. That means it is non-solenoid. Non-solenoid. Now let's calculate for the B2. What is the value of B2? It is e to the power minus a by e to the power minus y in bracket cos x plus sin x. Cos x ax plus sin x ay. Okay. Now we will differentiate it. So del cross B2 is equal to, when you differentiate with respect to x, this is e to the power minus y, which is common, and this is minus sin x, and when you differentiate it with respect to y, you will get minus 1 e to the power minus y sin x will be as it is. So again it is also not coming 0 or 0. Yeah, so it is minus sin x e to the power minus y and minus e to the power minus y sin x. So it is also not coming 0. So that is also non-solenoid. So both are looking as a non-solenoid. Okay, so you can also comment your answer in the comment section whether you are getting corrected or not. Come on guys. So are you getting the how to solve this? Okay, so in this way you can solve. Right? So this is the B1 and B2, both are non-solenoid. Option D will be the right answer. Okay. Now solve this question. The electric field intensity E at point P is given by 5ax plus 9ay plus 4az. If alpha, beta and gamma are the angles, not angels, it is angles, the vector E makes with the x, y and z respectively, then the correct options is or are. Alpha plus beta 88.5, beta plus gamma 104.2, alpha plus gamma 131.854, and 2 alpha plus beta plus gamma is equal to 230 plus 230.668. It is 2 marks, but it is the basic question actually. It is a basic question. If you have any idea about the vector, then definitely you will be able to do this. Chalo. So count it 1, 2, 3, 4, 5. So I hope that you have paused the video and you have started solving, and now you are actually got the answer, right? So let me tell you that this is an MSQ question. Okay, this is an MSQ question. So I hope that you might be getting that. Now you can again pause it and you can again try it. If once I tell you that this is an MSQ question, then okay. So let me write the vector E, which is given by 5, 9, and 4. So 5ax, 9ay, 4az. Okay. Now you want to find the alpha. Alpha is the angle measured with respect to x-axis. How can you calculate the angle with respect to x-axis? The angle with respect to x-axis is nothing but a cos theta. We are actually saying it as a cos alpha, right? Yes, cos alpha. So cos alpha is the vector E along with the vector ax divided by the magnitude of vector E. Okay, if suppose you want to calculate the dot product of the two vector, what it is? The A into B and cos theta. Okay, so I am taking the dot product of electric field with the unit vector. That means what? The magnitude of electric field, the magnitude of unit vector, which is 1, and cos of angle between them, which is alpha. So in this way I am writing it. Okay, now the cos alpha will be E dot x, so you will get 5 upon root over a square, that is 5 square plus 9 square plus 4 square. So you will get 5 upon root over 81 into 41. Okay, 81 into 41. Calculate it. 81 plus 41. No? So 81 plus, we are getting actually 11 point something, or you can say the root getting 122. So root over 122 we are getting. So the alpha is cos inverse of it is coming as the 63.084. So this is the answer that I am getting for alpha. Okay, so there is no option match because it is the summation of alpha, beta, and gamma. So now we have got one answer. Now similarly we will calculate the cos of beta. This is cos of beta is equal to E dot ay divided by magnitude of vector E. So this is 9 upon root over 122. So we will get beta is equal to 35.43. This is the second value that I am getting. Now coming to the next one, that is the cos gamma, is E dot az divided by magnitude of E. It is 4 upon root over 122 will give me the value of gamma as 68.76. Okay, so I am getting these three answers. Now let's check with the options. So alpha plus beta should be 88. Alpha plus beta should be 88. 6 plus 3, 9, 5, 3, 8. No, 98. It is 98. So it is not correct. Beta plus gamma is 104. Beta and gamma. So if I add 68.76 and 35.43. So this is 9, 4, 104.19 we are getting. 104.19. Yes. So this answer is correct. Now alpha plus gamma, if I add the 63.084 with the 68.76, so 4, 4, 8, 131, yes, 131.854, we are getting same, almost. And then 2 alpha plus beta plus gamma, so 2 alpha, that is 2 into 63 plus beta plus gamma, roughly 68 plus 35 plus 126. So we are getting 229 something. So 230, yes. So that all the three options are correct. B, C, D, three options are correct. So this is the MCQ question. And I hope that you have understood that, because the concept was simple. The concept was quite simple. Just the thing is that you need to apply the concept. This is a simple vector calculation. Okay, this is just based on the vector calculation. You can say that. Okay, it is just based on the vector. Now coming to the question number 28, the question number 28 says the potential field at any point in a space containing a dielectric material of a relative permittivity 2.1 and the V is given the magnitude of electric flux density. So we want to calculate the D. So D can be calculated as epsilon into E. Okay, so this is what we want. Okay, now I'm giving you the time. Just solve it. 1, 2, 3, 4, 5. I hope that you have paused the video and solved it. So now calculating the electric field first, because from the potential it is easy to calculate the electric field, which is the gradient. The formula for gradient is del V upon del X into AX plus del V upon del Y into AY and del V upon del Z into AZ. This is the formula. So minus of del V upon del X. So we will differentiate it with respect to X. I will get 10X and here plus XZ and AX cap. And when we differentiate it with respect to Y, so this is 3Z square AY. And when we differentiate with respect to Z, this is 6YZ plus 6X and it is AZ. So because we want to calculate the point which is 253, let's say what we are getting 10 into 220 and 626. So minus of 18 actually. 20 plus 18 is 38. So we will get 38. So 38AX and Z square 9 into 3 27AY. And YZ 15 into 6 90 and 90 plus 12 102. So we are getting this value. Now we want to calculate the D. So just simply you have to do that thing, that is epsilon naught into epsilon R. Epsilon R is given as 2.1 and the magnitude, because we want to calculate the magnitude. So let's calculate the magnitude of it. So it is 38 square plus 27 square plus 102 square. Okay, so let's calculate it. So in the nanocoulomb, it is 2.085 nanocoulomb per meter square. So answer is 2.085. Okay, so this will be our final. So this is a simple question. Now coming to the question number 29. So read the question and solve it by your own. I'm waiting for your answer. 1, 2, 3, 4, 5. Yes. So I hope that you have solved it. The displacement current density and the conduction current density in a medium epsilon r is equal to 2 is 2 milliampere per meter square and 89 milliampere per meter square respectively. So we have the displacement current density magnitude, it is 2 milliampere per meter square, and the conduction current density is 89 milliampere per meter square. The ratio of the displacement current and the conduction current is given by JC and JD. Okay, the JC is nothing but the sigma E magnitude I'm saying, and JD is omega epsilon into E. So in this way, when you calculate the ratio, you will get sigma upon omega epsilon, and it is nothing but the tan theta, which is nothing but loss tangent. But here we want to calculate the cos of theta n. So if you calculate the value of theta from here, this is tan inverse sigma upon omega epsilon. This is 89 upon 2 it is given. So in this way, shift to tan inverse, we will get 89 divided by 2, that is coming as 88.71. Okay, this is theta. What is the relation between the theta and the intrinsic impedance? So we know that this theta eta is equal to 1 by 2 tan inverse of sigma by omega epsilon. So from here, you should know that this relation is given by theta by 2. So whatever theta is this, the theta eta is 1 by 2 of this. So it is 88.71 divided by 2. You are getting 44.35. So the 10 cos now. So now the answer would be cos of theta eta, that is 44.35 equal to, it is approximately 1.707 roughly. Cos of 44.35. So it is coming as 0.715. I hope that you are also getting the same. So this is the 1 mark question. You can check your answer once. Waiting that all of you have got the answer or not. Correct? Correct. How many of you have got the right answer for all the questions up till now? Can you comment it? Yes, 0.715. All of you have got. Now, the last question. The last question, that is of 2 marks. The total charge present inside the boundary is. Okay, so first of all, this is the volume charge density given, which is looking a little bit complicated, but the total charge present, the total charge enclosed or total charge present is given by volume integration of rho v dv. So basically, it is given in your cylindrical coordinate system. So you have to write the limit of pi, which is from minus pi to pi, the limit for rho, it is 0 to 10, and for all that means minus infinity to infinity, and the value is 5e to the power minus 0.5 rho in bracket 5 minus mod of pi and 1 upon z square plus 10, and this is rho d phi dz, and all are in the micro. So in this way you have to calculate. Okay, now let's calculate it. The rho v is, let me write all the terms related with the rho. So 5 e to the power minus 0.5. So 5 e to the power minus 0.1 into rho multiplied with rho, and d rho. The limit of rho is from 0 to 10. And now we can write the 0 to pi. This is I am writing for pi. The pi is an even function, so pi minus pi and d phi, and limit will be from 0 to pi. So 0 to pi, pi minus pi d phi. Now let's write z. Z is equal to minus infinite to infinite. Then z is 1 upon z square plus 10. So 1 upon z square plus 10 dz. All are in micro. So now if you will solve it, this is 5 into rho into e to the power minus 0.1 rho divided by minus 0.1 minus of e to the power minus 0.1 rho divided by minus 0.1 square, limit from 0 to 10. Multiplied with 2, this is the pi square minus pi square upon 2, and this is 1 upon root 10 inverse z upon root 10 into 10 to the power minus 6. So check whether you are getting the same result or not up till now. Okay. Yes, absolutely. So now when we put the limit, we will get the 5 into, okay, so this is the 10 e to the power minus 1 divided by minus 0.1, and when we put 10 here, e to the power minus 1 divided by 0.01, and when we put 0, it will become 0, and it will be plus e to the power 1. E to the power 0 is 1 actually, and it is 0.0. And when you solve it, this is a pi square 2 into pi square upon 2, okay, and into 1 upon root 2 10. 10 inverse of this limit is from minus infinity to infinity, so 10 inverse infinity is pi by 2 plus pi by 2, and the result is 10 raised to the power minus 6. So check this integration, and when I am solving it, and I am getting 1295. When I am solving it, 1295 I am getting. So 1295 approximately 0.44 microcoulomb only we are getting, microcoulomb per meter cube. 1295 microcoulomb. Okay, so total charge present. Yes, I think that I have done written here. Actually, I wanted to write rho v separately, but this is the charge enclosed. So this is the charge enclosed. So now we have calculated the charge only. 1295. Okay, so the answer is 1295. So this is the answer. You can check the integration once, and I think it is correct, but maybe some mistake also. Calculation mistake may happen, so you can check it. Okay. Okay, guys. So thank you for watching this session. I hope that you have solved all the 5 questions of EMFT and the remaining 24 questions from other subjects correctly, and you can check your score that how much you are getting in this Independence Day. Thank you. All the best. Don't forget to subscribe our channel, and in the description there are multiple links are given, like you can register yourself for the Square test. You can also register yourself in the workshop. So there are separate initiative given to you, and also don't forget to download our BYJU'S Exam Prep app, because in the app we all are taking the multiple free sessions, quiz sessions for your practice. Thank you.